Okay, today we're going to add on to our note cards that we started on the last unit for sine and cosine. So all I've done is taken our sine and cosine graphs that we put on our note cards, and I wrote down the analysis of it below. So we're going to analyze both of these first, and then we'll get into the cosecant and the tangent and all the other four. Alright, so for sine of x, y equals sine of x, the period is 2 pi. Remember, we always graph two periods of these functions. So above we went from negative 2 pi to 2 pi on our graph. The domain of our function is going to be from negative infinity to infinity. Our range goes from negative 1 to 1. The symmetry is odd, and you can look at that by, or you can tell that by looking at the graph. And then for the extrema, the way that we're going to write that is going to be a little bit different. We're going to say that there is an absolute max of 1 that occurs at x equals pi over 2 plus 2 pi k. Now we write it this way because if you look at the graph, it occurs here at pi over 2. And then it's going to occur at that same height every 2 pi units. Okay, so if we were to subtract 2 pi from pi over 2, we'd get negative 3 pi over 2, and it occurs there again. Okay, also we need to include that k is an element of the integers. Okay, we also have an absolute min of negative 1 that occurs at x equals 3 pi over 2 plus 2 pi k. And since we've already stated that k is an element of the integers in this problem, we do not need to write it again. For increasing or decreasing, all we're going to write is that the function oscillates. And then there are no asymptotes in the sine function. Okay. Now we're going to do the exact same thing for the cosine function. Alright, our period again is 2 pi. The domain is negative infinity to infinity. And the range is negative 1 to 1. Our symmetry this time is even. Okay, and we're going to write the extrema for the cosine just like we did the last one, except for our values are going to change. We have an absolute max of 1 at x equals, and this time it occurs at 0, here at 0 degrees. So we're going to say it occurs at 0 plus 2 pi k, but 0 plus 2 pi k is the same as saying 2 pi k, where k is an element of the integers. Okay, and then we have our absolute min of negative 1 at x equals, and this is going to occur at pi plus 2 pi k. And we've already stated that k is an element of the integer, so we do not need to do that again. Again, just like the sine function, this is an oscillating function, so it does not increase nor decrease, and there are no asymptotes in this function. Okay. Alright, so next we're going to go on to cosecant and secant. We're going to start with the cosecant function. So all I've done on the next note card here is redrawn our graph, so and labeling our axes, and I've gone ahead and stated everything that we're going to find out about this function, y equals cosecant of x. Okay, just like with the sine function, the period is going to be 2 pi again, so I labeled my x-axis from negative 2 pi to 2 pi. And in order to graph the cosecant, we all know that the cosecant is the reciprocal of the sine function. So to get our graph of this, I'm going to go ahead and sketch the sine function on here, just the dots. I'm not going to connect the dots, I'm just going to put where the dots are. So, oops. Alright, so with the cosecant function, it is the reciprocal of the sine function. So what I've done is I put the dots for the sine function, and we are literally going to take the reciprocal of these. So I'm going to start here where sine is 0, okay? It occurs several times on this graph. Everywhere that sine was 0, when we take the reciprocal of that, we're going to have a number over 0, which is undefined. Those are going to represent some asymptotes. So we can go ahead and draw those in. Okay, now, and then everywhere that there is a point, basically our sine function came down and went up and came down, you know, so forth. What's going to happen is, I'm going to actually graph that for you here in blue so you can see it. That's our sine function, correct? So what we're doing is we're taking the reciprocal of all of those values. So basically we end up getting these little baby parabolas. So our cosecant function is going to look like this. We're going to have asymptotes everywhere that the sine function crossed the x-axis. And then basically we're just taking the reciprocal of all our sine values and we get baby parabolas. Alright? So when we go to analyze this, just like before, our period is going to be 2 pi. Our domain this time is going to be x cannot equal, and basically you're going to state everywhere there's an asymptote, okay? So we have one here at 0 and it occurs every pi units. So we would say x cannot equal pi k, where k is an element of the integers. Okay? Our range is going to be negative infinity to negative 1, which is included, union 1 to infinity. If you look at the graph, these parabolas down here both go up to negative 1, but will not cross it, and then we start again here at 1 and go on to infinity. The symmetry of a cosecant function is odd. Okay? And the extrema, the way that we're going to state this is there is a relative min of 1. So I'm talking about these ones right here. There's a relative min of 1 at x equals, and this is going to occur at pi over 2 plus 2 pi k. Because it occurs here at pi over 2, and then the next one occurs at negative 3 pi over 2. So that's like subtracting 2 pi. Okay. We also have a relative max of negative 1, so I'm talking about these ones this time, and that occurs at x equals 3 pi over 2 plus 2 pi k. Alright, just like with the sine and cosine are increasing and decreasing, we would just say that it oscillates. And this time we do have asymptotes. Your asymptotes typically are going to be where your domain does not exist. So in our case, it's going to be x equals pi k. Okay. So your domain doesn't include the asymptotes, but when you state your asymptotes, it is x equals pi k. All right. All right. Moving on to the secant. The secant we're going to do very similar. Okay, it is the reciprocal of the cosine function. So just like before, I'm going to go ahead and put the dots of the cosine function. Okay, now everywhere that the dots cross the x-axis, that's where our asymptotes are going to lie. Okay, and just like before, now we have to draw our little baby parabolas. The period for the secant function is the same as the cosine function, which is 2 pi. When we state our domain here, we have to not include those asymptotes. So this time we would say x does not equal pi over 2 plus pi k. K is an element of the integers. Okay, because our asymptote occurs here at pi over 2 and it occurs every pi units. Our range is from negative infinity to negative 1, union 1 to infinity. The symmetry of this function is even. And then for our extrema, we have a relative min of 1, and this occurs at x equals 2 pi k, because it occurs here at 0 and then every 2 pi units. And then we have a relative max, of negative 1 at x equals pi plus 2 pi k. All right, for increasing and decreasing, we're just going to put it oscillates. And then for the asymptotes, we would say x equals pi over 2 plus pi k. Okay, now we're going to go on to cotangent and tangent. Okay, we'll do the tangent function first. And as we stated in the last unit, the period for tangent is pi. So if you look at my graph so far, all I've done is graphed on the x-axis from negative pi to pi. All right, so you might want to grab your unit circle as we're going over this to help you identify some different values, okay? So as you're doing this, remember that the tangent is equal to sine over cosine, okay? So if we start at 0 degrees or 0 radian, remember we have the ordered pairs 0, 1. All right, so if we take our sine over our cosine, we get 0 divided by 1, which is 0. Okay, I'm next going to go to pi over 2. Okay, at pi over 2, we have 1 divided by 0. So 1 divided by 0 is undefined, so we're going to have an asymptote there at pi over 2. Okay. And then at pi, we will also have 0 because it will be 0 over negative 1. Okay, and that will be the same. Negative pi over 2 is going to be an asymptote. And then okay. All right. Now, also using your unit circle, we can figure out what the tangent of pi over 4 is, okay? The tangent of pi over 4, if you remember, is this blue line right here. We have the square root of 2 and the square root of 2. So if we divide those, we would get 1. Okay? And then if we do the tangent of 3 pi over 4, that's in the second quadrant over here, we are going to get negative 1. So that's this point right here. And then same thing over here, negative pi over 4, that is negative 1. And negative 3 pi over 4 is positive 1. Okay, and what's going to happen is our graph is going to look like something like this. So we're going to come up. Now, since I didn't, this would continue on, but I didn't graph it on my graph, and this one would continue down. Okay? The period of the tangent function is going to be pi. For the domain, we would basically take out those asymptotes, so x does not equal pi over 2 plus pi k. K is an element of the integers. All right, our range is from negative infinity to infinity. The symmetry of the tangent function is odd. There is no extrema in the tangent function. For increasing and decreasing, what we're going to say is it increases over its domain. All right, and then the asymptotes is just going to be x equals pi over 2 plus pi k. All right, we're going to do the same thing here with the cotangent. All right, remember the cotangent is the reciprocal of the tangent. All right, so basically if you can kind of go back to your tangent graph here. Anywhere it crosses the x-axis, that's going to be an asymptote this time. So we're going to have asymptotes at negative pi, 0, and pi. All right. And then anywhere there were asymptotes on our tangent function, those are going to become 0. Okay? So we'll have zeros. All right. And then for pi over 4, we did have 1, and the reciprocal of 1 is still 1. The reciprocal of negative 1, which is 3 pi over 4, is still negative 1. Same thing's going to happen over here on the other side. All right, so what you'll see here is our graph kind of flips and looks like this. Our period again is pi. Our domain is going to be x cannot equal pi k. K is an element of the integers. It's just pi k because it starts here at 0 and occurs every pi units. Our range, negative infinity to infinity. Our symmetry of the cotangent function is odd. There is no extrema. It decreases on its domain. And the asymptotes are going to be x equals pi k. Okay, couple things to remember when you're graphing these and analyzing the functions. Number one, make sure that you always include k as an element of the integers at least once per analysis. When you're graphing these, make sure that you graph at least 2 periods. Make sure that you label every tick mark that you put on your graph. Okay, so you'll need to know your fractions really well. Okay, and make sure that you state all your answers clearly and neatly.